If you came here to hear us talk about release engineering, you are in the right room. For those of you who are interested, my name is Tom. There will be a further introduction slide.
My name is Scott. There will be also the same slide.
So we have, yeah, slide economy. So our quick agenda is some introductions. Scott will go over the less good times. I will go over the better times, and then we'll have closing and questions, and then probably more questions outside in the hall if you are so interested. So my name is Tom Duffield. I am a release engineer with Chef. I've been there for some time.
5 years.
5 years? Coming up on 6 here, I think.
Yes, you will.
Yeah. That's my Twitter handle. Don't at me, I guess, or do. I don't Twitter very well. If you follow me, you're in for just a whole bunch of random retweets. Scott?
Yeah, I am Scott Hain. I am also a release engineer at Chef. I've been around for almost 5 years now. I also have a Twitter thing, but I also don't really use Twitter, so don't at me or do. I will respond in like 7 months and be like, oh, somebody. It happens. Which one of these buttons do I need? This one?
The one that has the forward arrow.
Cool. Thanks, Tom.
Yep.
So first of all, what we'd like to go through is a little bit of just some, the obligatory graph section where we talk about a bunch of different stats about builds and things in our infrastructure over the course of, let's say, the last year or 3. I'll get into more specifics on some of these charts, but just to kind of give you a kind of a rough estimate of what kind of throughput and what kind of things we have going on at Chef. Average build jobs per day is about 10,000. That includes canceled and aborted jobs, and it drops significantly on weekends, but still we have about 10,000 jobs that are started. These can be anything from Jenkins jobs, build kite jobs, other things. It's just a crap load of builds, essentially, so you can guess where we're kind of going from here. This right here is an average, and this is the count. This is, I believe, I only grabbed the last year of data. These are different projects, and you can see that some of them have been invested in during certain points in time more heavily than other ones. Also, nobody's perfect, so this little piece of data right here, we did an upgrade to the data collection thing, and we didn't notice that it wasn't actually collecting data for like a month. So that's just that's an anomaly. But in case you're wondering, this is Automate, the A2, the gigantic blue lines. And I want to say that this period right here was right before we actually released it the first time. And then you'll notice there's a bit of a jump in the number of jobs, and then it kind of went down as we didn't really do much development on it. That was I think that was ChefConf last.
That was ChefConf.
Yeah. So, you can see some interesting data here. There's also some other stuff where we released a bunch of cool things. What you can also see here is we added some different pieces of data for things like habitat finally, and this little red stuff here is habitat. And we're kind of getting down to a place where the builds make more sense. We're actually building smarter rather than just sort of building everything every time, all the time, which kind of leads us to the next thing. Well, actually, it leads us to a thing I'll talk about in 2 more slides, cost. But for now, this is the number of unique platforms that we have. I'm a nerd. That's a thing that is 33. It's the first 4 factorials added together. This includes AIX, Solaris, FreeBSD, macOS, Linux, and I'm not even going to get into the whole x86, Arch, Spark.
S390.
So here's our build just for the client, the Chef Infra Client project. This is our build matrix in Jenkins. You can see we've got some PowerPC, we've got some S390X, better known as Z-Linux. We've got Arch64, we've got all of these different separate things. That's pretty cool and that's pretty manageable. That's our test matrix. This is me thinking about the test matrix. So it's just not it's really hard to keep that straight, and when you have this running on a single Jenkins master, for example, your Jenkins master is kind of like, why? So, it
For the
works.
lulz.
We've been doing this for a number of years, and it works. So, I said I was going to talk about cost, so let's talk about cost. Our actual average cost right now is about $600 per day. This is just based on the infrastructure, the SaaS services we use, like AppVeyor, Travis, other things like that, and some hosting and et cetera. Does not include like our salaries and whatnot, and there's a lot of omission in here, but like just the raw number of like our EC2 bills and things like that is about $600 a day, which this is our cost for the last year. And Kibana is really fun, and it says, hey, you've got negative numbers here. You should be doing a different graph, which, yeah, we do, but they're negative cost numbers, and they don't make sense because we can't not be whatever. So a couple just real quick interesting things about this thing right here is you can see that our costs used to be pretty awesome up there in the thousands of dollars per day. We did a massive audit in, November of last year, and we actually consolidated our AWS accounts. We killed a bazillion machines. We moved a whole bunch of stuff around, and we resized some instances. And we switched to EC2 reserved instances because we were like, our utilization is 4% on 300 instances. Shit. So we still have spikes for when we have really big development cycles, when we have really big releases and stuff like that, when certain things happen. But for the most part, we're actually down to, I want to say that's about the 600-ish. Give or take. So that's been a huge cost savings for us, and it makes our CFO peoples and finance peoples much, much happier with us. So that's pretty cool. Next thing I want to talk about real quick is our team. And this is actually one of the most important things about this whole thing. Our team is awesome, by the way. It's really great. Like half of them are in the room, or all of them are in the room, maybe. No, we still have a couple of folks who couldn't make it. But the point I want to make about this is this team has existed and been fully funded in one form or other as a release engineering services, build team kind of thing for, I want to say 6 years, 7 years? I want to say, yeah, and it's been at least 2 or 3 people the whole time. We have team working agreements so that we all are on the same page in what's expected, what everything is doing there. And the other thing that we pretty much do for this is we really hire for problem-solving skills and for how do you learn things, and not actually for a specific technology, because that's the way that we have found the best people who can keep things like that Jenkins diagram I showed you in their head and be able to reason about that and go, oh, this problem, this problem, this problem, this thing, oh, that's probably what we need to deal with next. So it's pretty great. I'm just going to take a quick sip of water before we get into this.
It's not water.
You'll see when I... So how did we get here? I also wanted to just quickly thank a couple of people, SSD and Dan, and a couple other people who were involved with this from the very, very beginning, who helped me get some of this data. And this was kind of an archaeology project because this has been in the evolution of our infrastructure has been a constant affair, much like, like if you saw Brittany's talk earlier, talking about you've got to keep iterating and iterating and iterating and iterating, and that's what we did with this right here. Keep improving, and things don't always work out great, so sometimes they do. And any errors in this are my own, so Dan, Steven, you guys, sorry if I didn't quite get it right, but this is close. Okay, first we had a chef server, Andra. That was pretty cool. It was the chef infra server. It ran chef server jobs, and it ran in Closet CI, which was literally a machine in a closet. I don't know whose closet it was, but it was running KVM, and there were some images on it. And I believe, this was before my time, by the way, I believe that the chef server was manually put together at that point in time, just all UX, connecting things up, manually starting the Jenkins like agents and stuff like that, going from there, etc. It worked. Then we had the MacBook, which was a MacBook that was closed about this far, and it had a sign on it that said, "Do not close," in like all caps. And there was a funny little thing about that where every couple of days we would find out that it would disconnect. And it would disconnect from the Jenkins server, and nobody could figure out why until we realized that there's like a extended screensaver that goes into sleep. Even if you have the screensaver turned off, like it'll go into a screensaver mode after like 4 days or something like that. And when the screensaver comes on, it would actually disrupt the Jenkins connection. And then all of a sudden we would lose the MacBook. And then somebody would have to go into the closet and open up the MacBook and move the mouse and log back in and restart Jenkins. Woo! Yeah. It's pretty awesome. At that point, we were publishing our things to S3 directly. There was an S3 bucket. We were like, packages, go here. Enjoy. Huzzah. That's really great customer experience, I'm sure, to be like, go to this S3 bucket that is open and download our package from there. It's probably cool. Trust us. About that time, a little after that, we started actually building out the Chef Infra client, which previously known as the Chef client. We had another a separate Jenkins master called Manhattan that we set up just so that we could keep those separate. There were a bunch of other things. The platform breadth, as you can guess, and like from what I showed you earlier, was a lot bigger. There was a lot more there. The server projects historically have only had like a few things that they are run on. Manhattan, like we actually had a little bit of AIX, a little bit of Solaris, and those kind of things. But then we had the OpenStack cluster. Shout out SSD. Or not, sorry. And that ran pretty much perfectly, unless people who didn't know how to use it tried to use it, in which case they would go and ask Steven, and he would be like, I'll fix it. Because it was not his job. It was just, it had to happen. That shouldn't have happened so quickly when I pushed that, because Closet CI was still there for a little bit longer, and I believe OpenStack ended up as being Closet CI version 2, but the concept remains the same. Somewhere in this time period, we started actually getting Windows machines. And we had them in Azure, which was really great because we had a bunch of stuff like OpenStack in our data center at that point in time, or it was eventually moved to our data center. We had Windows in Azure. We had the MacBook in a closet somewhere. We had Manhattan on, it was in the closet too, actually, now that I think about it. And there was like 1 or 2 VPNs, and connections from Azure had to go across a VPN to another. I could go on. It was, we would lose Windows machines like that because it was going through like 4 VPNs, and it's really sad. So, finally, let's replace the MacBook, shall we? Let's get some Mac Minis. we'll get some Mac Minis, we'll actually put them on top of another machine in a data center, which is fine because it's not a MacBook that sometimes people just close because it's on a rack and you're like, I should probably close this. They were running Fusion as well. I didn't mention that earlier, but they were running Fusion, so we would actually be running like 4 or 5 machines on them, VMware Fusion. And that way, that worked pretty well, actually, unless something weird happened, like the screensaver turned on, or they got logged out, or Apple pushed out a update and they rebooted, or things happen. And so then finally the Mac went away, or the MacBook went away. Then we started using EC2. Yay! There's actually one tiny anecdote that I want to tell real quick because it's important. Before we moved Jenkins, all of Jenkins to actually the masters to EC2, we had this little thing that happened. And what happened was, it was about, I want to say 3 months before the release of Chef Server 12, which was a really big thing for us as a company. It was open source Chef Server, and it was great. Like we were really stoked about it. Everybody was working really hard. There was a lot of builds going through. And then suddenly, the Chef Server masters just disappeared. And we were like, okay, that's a problem. Because it turned out that the thing that was behind them, that all of the Jenkins stuff was running, the home directory of Jenkins was running on a mapped shared drive that was connected to a Ready NAS with 5 drives that was in a closet at the office. And it had lost 2 drives, but there was no monitoring there or anything like that, so it was just gone. And so we were like, shit, what do we do now? So through a little bit of some weird heroic efforts, we found a backup copy of literally just like the entire subdirectory of it that somebody had just made for some reason from about 6 months ago. That was it was in some some S3 bucket. We dumped that down, rebuilt the thing as fast as we could, did a bunch of manual stuff, and revived it. And I don't even remember. Do you remember how many days we were down for that? It was like a week and a half. That was really bad. So back up your stuff, know where your stuff's running, just, Eventually, we then said, Andrea has to go as well, and we built Wilson, which was going to be the new Chef Infra Server host thing, and Andrea went away. We also replaced the backend with Artifactory because having S3 bucket for a backend is not as great as having Artifactory that does backups and has logs and has auditability and et cetera, et cetera, et cetera, et cetera, et cetera. Lots of good things come from that. Button? There we go. Over this whole time, we'd had some Solaris stuff. It had mostly been manually run. I'm going to speed up because you're looking at me and I'm going too slow, sorry. Okay, we had some Solaris stuff. We had some AIX stuff. This was hardware in our data center. It was cool, but it was all really manual. People had to log in and fire it up. Ask Dan sometime about the time the AIX machine lost DHCP and just suddenly didn't exist anymore. That's fun. We got rid of the OpenStack cluster because we moved everything to the EC2 cloud. Then we started building, instead of using the Mac Minis because we started having capacity issues with that, we actually built out a Mac Pro cluster running ESXi and vSphere on it so we can actually run all that stuff. That's in the data center as well. That went away. Windows moved to EC2 finally, so we didn't have to worry about that other vSphere thing that we had that was, or Azure thing, I think it was blech. And then we had a bunch of other more unique things that we have added in different clouds and different areas over the course of time that have been a lot of fun to deal with. And I think, and then the last thing that we've been doing right now is we've actually been migrating some of our Mac stuff onto a service called Mac Stadium that uses Enka as an underlying technology, which is really fast and really awesome. So I'm going to blast through this slide real quick because this one is my last slide before it's Tom's turn. And we're doing great on time. So this is actually what it looks like right now in our entire infrastructure. This is the Chef release engineering thing. And I'm gonna, sorry dude, I just walked in front of the taking picture. I'm gonna draw some lines here so you can see the interconnections of some of these things. Things that Jenkins has to touch. Jenkins clusters over there, all of these things. Cool, no problem. Things that talk to Artifactory. These are all connections that have to go one or the other. There are arrows, but you can't really see them after all of the freaking lines. Things that would break the world if they didn't work. Talking to GitHub, that's not cool. Talking to either of our Jenkins servers and our automate server, like that would be, which is actually supposed to be here as well. That arrow is supposed to be there. So those things would all make it so that our entire infrastructure no longer functions. These are all the things that are under Chef control. So we have the Chef server, we have cookbooks, we have everything. There's a Chef client running on all of these things that is converging. It's running, I want to say it's running current. So if we release a bad version of Chef client, we'll know real fast because within half an hour because everything just stops working. Then there's a connection from like Automate to Habitat somewhere. There's the Linux nodes are connected to another thing there. There's more stuff that Habitat talks to, like Docker. There's a connection between GitHub, Manhattan, Artifactory, and the Linux nodes, and also RIP Grumpy Cat, Tartar Sauce, died last week. But the point I'm trying to get at here is no human can keep that shit in their head. And trying to go up to somebody and being like, okay, let me map out our infrastructure. Anthony, let's talk about this. You're a new person at Chef. Let me explain to you how, let's go get a drink. Because it's while it is very tightly controlled and everything is there and everything is connected, it's almost impossible unless you've been doing it for years and years and built it to like actually keep this and this model in your head and understand that if I change this, what's going to happen over there? So that's the thing, like even Seth, who wrote 50+% of this, like, I bet you're just going like, it does what? On some of that stuff. So the great news, we're building a better way.
Yeah. I'm assuming you're all very sad at this point, right? So who here has knows how all of your applications in your company are released?
Chef people, put your hands down.
Timberman knows. He knows it's this. So I didn't always work in release engineering. I used to be a consultant. I used to go to customer sites and was on the sad end of that previous graph. Or maybe not as sad. You were on the sad end. I was on the good end, I guess, of that. Anyways, at one point, I was put on a team that we used to call the pool teams. Like we were rotating through teams, and it was your responsibility to like merge pull requests and release the products. So it's like, hey, it's time to release a new version of Chef DK, or hey, it's time to release a new version of Chef Client. Go do that. I was like, great. How? There's a doc somewhere in a Google Drive. Go find it. Cool. So Expeditor is the culmination of a lot of sadness, rage, and one very fun road trip that I will now go over with you. So the important thing what we've learned from all of the sadness is to approach this with systems thinking. You want to kind of break things down into pieces that you can understand, and then make sure that you understand how all of those pieces interact, and try to keep as much consistency amongst all of those things as possible, while also understanding that at some point someone's going to want to do something weird, and you're going to have to be able to support that.
Different, not weird. Just
no, it's weird. It's different, but it's weird.
I bet you they have a really good business reason for doing it, though, and we should let them.
I'm sure they do. And the crux of all of this is everything should be as code. That's kind of our company motto. It'd be really weird if we didn't adhere to that. So you want to keep your release configuration as code with the projects, so that when you're looking at how do I release thing, you go to things repository, and you can look at the code, and you can see, okay, this is how it's released. What that means is because all of your release infrastructure, or all of your release processes are kept with the different projects, you don't have this high-level kind of command and control structure about how things are released or how things interact. You don't have one central knowledge base of when this happens, then this happens. What you do is you have a reactive model where if this happens, then something else happens. So if a GitHub pull request is merged, then we want to do something. If a new version of ChefConf for client is published to Artifactory, then we want to build a Docker image of it, that sort of stuff. And what we do is we call those things action sets. Right. So you want to break things down into actions and events. So events are the things that are happening within your ecosystem. A pull request is merged. You've promoted a version of an application to a new channel. Some scheduled event is happening. Like it's 3 a.m., it's time to back up the docs site.
Not a real example.
Right? And then you have actions, simple things like bumping the version of your application. When a pull request is merged, you want to automatically add some details to your change log. You don't want to have to manually, at some point, 6 months after I remember having to manually craft change logs, like going through pull requests, copying titles into a markdown doc. No more. Or don't even get me started on the GitHub changelog generator. Or building a Ruby gem, or just something as simple as running a bash script. When you break things down like that, you can do basically anything that you want in your release engineering ecosystem, as long as you can associate some actions with an event. So let's kind of go through an example. So we're going to talk about, no? Okay.
Sorry, I was inhaling. Continue.
Blink quieter. So here, in the middle, you see this little orange circle, that's Expeditor. Expeditor is a service that runs on a machine that you can't access, I'm sorry. But it's there. And what's happening is a whole bunch of things are talking to it. Things like Artifactory, BuildKite, GitHub, Docker Hub, Slack, bin tray. What?
Can I clarify one statement that you said there?
Sure.
It is listening to a whole bunch of things that are publishing events. It is not actually receiving messages from things. Yeah. It's a nuance. Carry on. I'm being pedantic.
Okay, we'll have a conversation about that. So, as an example, GitHub notifies Expeditor that a pull request has been merged. So that event gets sent to Expeditor. Expeditor reads the Expeditor config that's kept with the source code for the Chef repo, and it says, okay, I know that when this event happens, there's some actions that I want to do. And so I'm going to do those actions. I'm going to bump the version. So I'm going to increment the patch version or the minor or major if you've applied the appropriate GitHub label. I'm going to update the changelog. I have the full GitHub webhook payload. I know what the PR title was. Let's just put that in the changelog. Some fun regex in Ruby, and it's all good. And then we commit those changes back to GitHub. So we can make a commit and we push to master. Make a tag for that commit, and then we trigger a new build. For ChefConf for client, the ideal solution is it gets triggered in BuildKite. Right now it gets triggered in Jenkins, but what the config says is it tells you where it's being triggered. It says, I'm triggering you in Jenkins, or I'm triggering you in BuildKite. So it knows.
You define the actions.
Yes, you define the actions. The actions are code, they're YAML. I did that only to annoy Joshua Timberman. Yeah. So you can look at the code and you can actually see over time what the release process is, how it's changed. You can put comments in. So if you need to temporarily disable, say, habitat builds for reasons, you can put a comment in there that says, hey, we need to temporarily disable this just to get some releases out. We'll turn it back on later. And all that's as code, so you have the commit history and you can know who's responsible for it. Yeah, could be anyone. Could be anyone. So then the BuildKite pipeline will build the omnibus stuff. And all of the information about how to build the packages is kept in other source code repositories about like this is how you need to build this omnibus package. It's all code. It's all linked together. You can see what it is. But when it's done, it gets uploaded to Artifactory. And when that's done, Artifactory then notifies Expeditor that a new artifact has been uploaded. We have like a little post thing that just sends a HTTP request into Expeditor that says, hey, this package got uploaded, which is super cool. So now there's a new event feeding back into Expeditor. So then Expeditor is like, cool, an artifact just got uploaded. What do I do when that happens? And the configuration will say, you need to now build a Docker image based on that artifact. So then Expeditor will trigger an action to build the Docker image and then publish it to the Docker Hub. All of that's like that. What happens when you want to promote it? We have a Slack bot that allows anyone that is on the right team, so I shouldn't say anyone, that allows pre-certified individuals of reputable whatever, to promote a version of the product. So it's literally like Expeditor promote chef 15.0.300. And what it will do is it will then, that sends an event into Expeditor, and Expeditor says, cool, I just received a special customized event. What happens when I receive that event? I take some actions. So I will promote the artifact to the stable channel. That's an event. That's an action related to Artifactory. We need to add a tag to the corresponding Docker image on the Docker Hub, so it makes an API call to the Docker Hub to say, add this tag to this image, corresponding with the channel, so you can do cool things like follow the current channel in your Docker image. We also want to update the changelog. So when we promote a version, we want to kind of collapse all of the changes that have been merged into one big header so you can kind of see what's been changed since the last stable version. And then we also want to go notify our announcements channel in Slack to tell all of our fun salespeople that, hey, we just announced a new version of Chef. Here's a link to the changelog. Here's the release announcement, which can also be auto-generated.
Does it send it to the community chat as well? I forget.
Not yet.
Not yet. That's right. I can remember.
We're working on it.
Yeah.
The other thing that happens is when that promotion occurs, Expeditor can actually respond to itself. So when we promote ChefConf for client, we can actually the ChefDK project can
Workstation.
Chef Workstation. Thank you. I think technically both still do it.
I know.
But Chef Workstation, which depends on ChefDK. Anyways, the Chef Workstation project can subscribe to that event. It can say, hey, the ChefConf for client was just updated. When that happens, I want to update my pinning that I have in my gem file or whatever it is. And we can actually just write a bash script that does like some sed replacement and open that up as a pull request. So then a very reputable human will come along and review that pull request created by our future overlord of automation and decide whether or not to merge it.
The other thing about that is that also happens, but you didn't even mention, is that the pull request is opened. That's an event.
Yes.
So then all those testing that we described earlier, that all runs through CI again.
Yeah.
All of that cycle that happened earlier, simply because a version of this thing was promoted, which caused an update to this thing, which then got a PR automatically created, which then kicked off builds for the jobs, which kicked off all of this. So it's literally a chaining of events.
For the most part, every action in the system creates a corresponding event that you can react to. So we just recently, like if you've opened up a pull request on any of our projects, you've probably had to do DCO sign off. That's run entirely through Expeditor. Expeditor is responding to all of the events from GitHub. And like Scott said, like basically everything that we do in release engineering can be reacted to by any project that's currently using Expeditor. Okay, but why though? So I'm going to let Scott go first here.
Right, yeah, so there's a couple of reasons. Tom will talk about the other ones, but two of them that really, they really speak to me is you have full auditability. You can take a action and see what caused it, what piece of automation or person actually went and did the thing that caused it all the way down in both directions. And it's very, very, very easy to see that because you have not only a record in your logs, which are, they're logs, there's a lot of them, you don't want to look through them, but it's usually in GitHub or your source control if we get to that point, but like it's in your source control that this thing did a thing and Expeditor did it, also it was caused by this thing. So you have this really, really beautiful audit trail that it's so easy to follow. The other thing that I really like, because I came from an enterprise a while ago where there were some very, very strict rules about everything. So the ability to have escape valves where you can actually go and say, you know what? This thing doesn't quite fit the workflow that we are allowed to do by our other team or the change board or whatever it is, but we can tweak it, we can make our own action, we can make our own thing to respond appropriately and fit it into what we are allowed to do under the constraints. The other thing, well, yeah, you'll talk about the other thing.
Yeah.
Yeah, so.
A good example that you could actually go look at today for escape valves is we have a built-in that allows you to promote the habitat package associated with the code repository in response to some action or some event. That's a built-in. So rather than having to write a bash script that like makes curl requests or runs hab commands, you can just as long as you're following the conventions, you just put that as an action in response to an event, say the project promoted event, and it will do it for you. But our Automate project, Chef Automate, has a slightly different package promotion scheme that doesn't quite fit with that built-in. So they can just write a bash script that can do what they need to do, and that allows them to kind of make sure that things are working for them, while everyone else can kind of keep using the consistency that we want, and then we can iterate on that bash script and maybe incorporate some of the learnings into the built-in. So it's great for experimentation. So the release context is kept with the source code, and that allows for faster onboarding. So when you're looking at a project, you know, okay, this project is using Expeditor because it has an Expeditor folder. I go in there, I'm going to see the config file, and I'm going to see all of the bash scripts that Expeditor is going to call, all of the build kite pipeline definitions, all of that stuff is going to be in that project directory. And you have, for things that aren't, there is extensive documentation that I have written about all of the different built-ins do. how they operate, how they're supposed to work, what is the configuration. And that's searchable, and if for some reason that doesn't answer your question, you can go look at the source code if you're a Chef employee.
Well, I'm going to say they can't.
Right, well, some of them can. The ones that are Chef employees can.
This is true.
And the nice thing about having this kind of central thing of here's how we do release engineering, such as like Expeditor, is that's kind of your dumping ground for all of your how. That is, even if it's not directly related to Expeditor and it's just this is how we do release engineering, that's a place where you can put it. So we can document things like BuildKite and how it works and how we interact with it, and Mac Stadium and Jenkins and all of this sort of Builder, that sort of stuff. Like our patterns for how you want to do things, like we have a common place where we can put it. And so we create this environment where Expeditor is synonymous with release engineering. So if there's a release engineering question that you might have, you know where to go look for it. You just have to go look for it in the Expeditor configuration or the Expeditor website.
And it's kind of important to note that, and you said this, but just to really drive it home, is that not only are the actual processes for the release codified with the repos, the processes, the generic processes that we use for release engineering are also codified and documented in the Expeditor site. So you have multiple layers, and you can cross-reference if, like, wait, what does that do in the YAML thing again? Oh, let me open up the website. That's exactly what it does. Got it.
Mm-hmm. So that's all we had prepared. Does anyone have any questions?
Oh, wait, show the tool, or are we going to do that?
We also have a little slide with all of our toolkit.
Yeah.
When the slides get posted, you can do that. I just wanted to include that there.
Yeah.
So.
It's all good things.
Yeah.
But yes.
Questions? Thank you.
How much of a bribe do I need to give you to get my name on this list right here of the repos that can use this thing?
How much would you have to bribe me to let you use Expeditor?
We're working on the community distribution stuff.
Yeah.
Like it's solve a lot of our issues, and even outside of that context, I'm thinking just like my chef cookbooks on my dependency tree, despite my best efforts to keep them simple, it can get a little bit complicated.
Yeah.
Yep.
What I will say is that we are in the process of putting a lot of the learning that we've done from Expeditor back into projects that already exist. Mm-hmm. So for the foreseeable future, as far as I'm aware, Expeditor is not a thing that would be a product or a service that Chef, the company, would offer to its customers. That doesn't mean that the functionality or a lot of the stuff that we're developing internally won't make its way to customers as part of other products.
In some form or other.
Yes.
And a lot of the things that Expeditor does as far as version bumping, all those commits go back to the
Yeah.
Yep.
So for the community distributions, you can take advantage of a lot of
Yeah, like the community distributions will get auto bumping, but the other thing is there's an element of control that we want to, like process control. So like we're kind of enforcing stuff on the people who are using Expeditor. And that's part of the reason why it's not open source. Is like there's a lot of like chef-specific practices that
and
are
auditability that we need to keep.
Yeah. So I'm really sorry. I would love it if we could just open it up to everyone. We're working towards a world where you can take advantage of some of the stuff that we're learning from. But I wanted to.
Yeah.
I think you essentially answered it. It's like, is it open source? No. And will it ever be open source? And it sounds like
No.
We've been talking about it. I don't have an answer for you. The problem is it's so chef specific.
Hashtag it's complicated.
Yeah, it's so chef specific that even if we did have the source code open, it's very unlikely that we would probably.
the pattern that
That's-
Expeditor does, the events and the actions, we could see that moving into some of our other products. And
That's kind of key.
now,
Yeah.
at that point, things would.
Because if you look at like, and I would highly encourage, if you're interested in this, go to any of the ChefDK, Habitat, any of those repos, and check out the .expeditor folder in the root of it. You'll see kind of the structure of it. That stuff's the configuration and the things that it does are all open. And this model that we're describing here with the event action model, that's really the thing that we want to get across. Like that little piece of the service that does that is what allows us to do those things. So you may be able to leverage, like in your example with the community distro, like you may be able to leverage a lot of what already exists in terms of the actual mechanisms that do the running and the versioning and all that stuff. You just won't be able to use the Expeditor tool itself to do it at this point in time. So,
Yeah.
it's worth asking.
Yes.
Are the event listeners in the non-Expeditor folder as well, or just the actions?
Just the configuration. The event listener definitions are part of the Expeditor code base itself. We basically have like a Sinatra app that's listening, that has like endpoints for different services, where we receive the payload, process it, and then send it into the system.
It's just,
Or is the definition of, is there a definition that says, you know, on git commit do action?
Yes.
Or that's all Expeditor?
No, so that's a subscription. So the subscription of like when this happens, do these action sets, do these actions, that lives in the code, in the project code, not in Expeditor, very purposefully.
yep. We wanted to take as much of the project-specific stuff out of Expeditor itself.
Yes.
With your pipeline, have you integrated any security tool for test and SAST for security scanning before you move your code to the RTUs?
We do some sort of scanning. That is part. It kind of depends on specific what kind of security scanning you're talking about.
Probably not in the way that you're asking about, but we do run in certain things in our acceptance environments, we do run inspect tests against the thing, but we don't run like, for the most part, like pen testing type things. Yeah.
Well, like there's not a dedicated like pen test pipeline.
Yeah.
But we do.
Yet.
Well, yeah, we do things like run inspect against a machine that's been configured by Chef.
Yeah, which we are doing it too.
Yeah, and so like we do that as part of like our dev and test environments too. So before.
We got to run when you're done, so we'll be outside, but
Yeah.
continue. Sorry.
Sure, I'll talk to you later.
Yeah.
So, yeah.
He's been giving us the thing.
That's cool.
Thank
Thank
you.
you everybody for coming. We'll hang out if you have other questions.
Yeah.
But